Okay, guys, real quick video on probability models. This is pretty much just talking about simple theoretical probability. So the sample space you can use S to represent a sample space of a chance process is the list or set of all possible outcomes. A probability model is a description of some chance process that consists of two parts, a sample space S and a probability for each outcome. So let's talk a little bit about a sample space. So a sample space can be real simple, just listing out the possibilities. So for example, if we are listing the sample space for a rolling two die, we can roll a 1 and a 1, we can roll a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, or a 1 and a 6. Or we could roll a 2 and a 1 and a 2 and a 2, a 2 and a 3, 2 and a 4, a 2 and a 5, a 2 and a 6. Or a 3 and a 1, and a 3 and a 2, and a 3 and a 3. And you get the point. And as a really fancy model, I will show you this. But clearly, if you had to list out a sample space, it would be very time consuming to draw little individual dice, so you wouldn't realistically do this, but it's a nice little picture to look at. So in looking at our sample space, we can clearly see that we have 36 possible outcomes in rolling two die. So let's talk about what an event in probability may be. So an event is any collection of outcomes from some chance process. That is, an event is a subset of the sample space. Events are usually designated by capital letters like A, B, C, and so on. So if I said to you guys, let's define event. Let's say event A is going to be, how about rolling a, let's say rolling two even numbers. Okay, so if I ask you what the probability of rolling A would be, we know that probability in our has to be your favorable events or your corresponding events to its total. So the total here, 36. Let's find where both are evens. So clearly you're not going to have any here because you will have all ones. Let's look here. I got a 2 and a 2 and a, and a 4 and a 2 and a 6 and a 2. You have all threes here, so it's not going to work here. Here you have your 4s and 2, and your 4 and 4, and your 4 and 6, and you have your 5s here, so it's not going to work there. And let's see, we have our 2 and our 6, and our 4 and our 6, and our 6 and our 6. And so the probability that both will be evens is 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 36, and we should reduce our probabilities to 1/4. Okay. Okay, so let's talk about the probability maybe now. Let's change the situation. This time we'll talk about the probability of A, where A now is the sum of, that the sum will be 5. So let's see. So for 5, we'd have a 1 and a 4, a 2 and a 3, a 3 and a 2, and a 4 and a 1. So we have four total possibilities. We have four favorable outcomes. Four outcomes correspond with that event, and there are 36 total possibilities, and there would be the probability of rolling a sum of 5. So now, if I asked you, for what is the probability of B, where B would be defined as the sum is not 5, well, we could do this the long way, which is list out all the ones that are not 5, or we could always go back to my sample space here and say, oh, okay, well, all of my, oh, what's going on here? Oh, that's not working. Okay, anyways, we can find all of the numbers that are not a sum of 5. So we could say, oh, well, 1 and a 1 and a 1 and a 2 and a 1 and a 3, but this would take us a very, very long time. And so it is probably much easier to say 1 minus the probability that it will be a 5. So this is the idea of our complements that we spoke about, we will speak about in the next video. So it's probably much easier to do 1 minus the event that would actually occur because your probabilities have to total 1. So the probability that it would occur, we did on the last slide, was 4 over 36, that it would be a sum of 5. And so this is easy enough to do. So we're going to do 36 over 36 minus 4 over 36, which is 32 over 36 would be that the 2 die will not be a sum of 5. And then finally, and we are done, the event that the sum is 6. Okay, so this is easy enough. So we'll do this really quickly. So let's see, we would have a 1 and a 5, a 2 and a 4, a 3 and a 3, a 4 and a 2, a 5 and a 1. So that gives us a 5 out of 36 as our probability of rolling a sum of 6. Okay, so what if I asked you for the probability of rolling A or C? So A was our sum of 5, and A was our sum of 6. So what's the probability that I'll roll a sum of 5 or a sum of 6? So whenever you see the word or, it's going to pretty much increase your possibilities because you're saying one or the other is favorable. So the probability that it was a sum of 5 was 4 out of the 36, plus the sum of 6 was 5 out of 36, and so 9 out of 36. Okay, the idea of this word or, but we're going to write that, or we'll look at that more in depth in the next video. Or in probability is going to tell you to add. Okay, sometimes you do have to be careful because there may be an addition and then a subtraction also involved if you are looking to count something more than once, but in general, when you see the word or, it should indicate to add. So no check your understanding at the end of this video. You'll see the check the understanding that goes with this one at the end of the next 4.3 video. See you later.